Live from the lab.
That's so crazy.
Could it be this love has burnt out? I guess I just thought that I could be there for you. I guess I just thought you would be there for me too. Me too. Have we realized we faded, dissipated from view?
Every cell, because like obviously so many cells. Well, okay.
This love was so visible. So
Good afternoon, everyone. Today we acknowledge and pay our respects to the traditional owners of the land on which we meet. The traditional owners of the land on which both the University of Sydney and FBI radio station is built are the Gadigal people of the Eora Nation. If you are joining us from lands that belong to other traditional owners, we'd love for you to share this and expand our acknowledgement in the chat stream. Together, may we pay respect to the knowledge embedded forever within the Aboriginal custodianship of country. Hello everyone, welcome to Live from the Lab, where music, science and art meet. I'm Associate Professor Alice Motion from the School of Chemistry at the University of Sydney and Sydney Nano Institute at the University of Sydney too. And today I'm joined by the fabulous Courtney Ammenhauser from FBI Radio. Hi Courtney, do you want to say hello?
Hello, I'm Courtney. As Alice said, I host Up For It, the breakfast show on FBI Radio, 6 till 9, Monday to Friday. Let's tune on in to the show. Together, Alice and I host a science segment every Tuesday on FBI Radio. But last week, we expanded and did it every day for Live from the Lab, and it was very exciting.
Yeah, it really, really was. So we brought Live from the Lab to FBI Radio in partnership with the University of Sydney Nano Institute and with support from Inspiring Australia. And for those of you who didn't get a chance to hear Live from the Lab, fear not, you'll have a taste of it today, but there will also be podcasts and videos aplenty coming, which we'll tell you more about. Live from the Lab is something that we've been working on. The nugget of this idea started on FBI Radio about 5 years ago. As Courtney mentioned, I come on every Tuesday and get to share science stories with the listeners on FBI Radio and learn some more about the music that's being played there too, and I really look forward to it. Before Courtney, I had the pleasure of working with 3 other awesome hosts, the first being Georgia Hitch, and it was with Georgia Hitch that we first invited Sean Conran from Obscura Hale onto the show to compose original pieces of music in response to pieces of science that had come out into the scientific literature just that week. And he turned around these pieces of music, fabulous ones, very quickly. And we've been wanting to build on this for a long while. And this year, with thanks to support from the Sydney Nano Institute and Inspiring Australia and National Science Week, we were able to combine 6 researchers who are from the Grand Challenge projects at the University of Sydney Nano Institute. And each of these projects is just amazing research. The researchers behind them are trying to solve really big societal problems using nanoscience. And you're going to hear a sneak peek of some of those projects today. And most importantly, you're also going to meet the musicians who've been partnered with those scientists and were asked, after a 90-minute Zoom conversation with their researcher or researchers, to compose an original piece of music that was an emotional response to that conversation with just a 2-week turnaround. And the results have been fabulous. So today, we invite you to join us for a listening party and a panel discussion so you can hear more of this music, learn more about the science and meet these fabulous artists. So Courtney, I think we'll take it away with the first pairing for today. So but before I introduce these researchers and I just let you know about the format, we're going to hear a bit of this music from each of them. I'm going to introduce the scientists. So today we have Dr. Taylor Siska and Min-Tree Liu, who are both from the School of Chemistry, which is a school that's very close to my heart, at the University of Sydney. Min-Tri Liu is currently doing his PhD with Dr. Shelley Wickham and Associate Professor Ali Abbas in the School of Chemistry and the School of Chemical and Biomolecular Engineering at the University of Sydney. He was awarded his bachelor's degree in chemical engineering back in 2015, and his research interests are in the self-assembly of nanostructures using DNA as the building block. And you'll hear a little bit more about what Min's up to in a moment. And Taylor is originally from the USA, where she earned her Bachelor of Science in Biochemistry at the University of Arizona. She then did a PhD with Professor Joel Mackay at the University of Sydney, and now she's in the lab of Dr. Yuheng Lao at the School of Chemistry, where she's looking at a protein nano compartment that's called encapsulant. Again, we'll hear a little bit more about that from Taylor. And Taylor has been involved in a huge range of outreach, particularly to young school-age children, and she's been on Channel 7's Get Clever, along with many other events. So there are scientists, and Courtney's going to introduce our first musician.
Yes, so Luke Davis is a Sydney-based musician, performer and creative who produces original songs featuring lavish soundscapes and soaring vocals, along with imaginative visuals to express his yearning and curiosity for life and how things come to be. So What We Will Become was his debut 2019 record that explores bittersweet nostalgia and reluctance of moving into a new stage in life and coming into one's own.
So I think it's probably time that we heard Luke's track that was composed in response to the work from the Nano Robotics for Health group. And this piece is called The More I Think, The Bigger It Gets.
The more I think, the bigger it gets. The more I think, the bigger it gets. The more I think, the bigger it gets. The more I think, the bigger it gets. It's such a small thing, and it swallows me. Oh, vision total blur. Are you what I thought you were? The lungs are screaming, let me be heard. But the more I think it, the more I think it, the bigger it gets. The more I think it, the bigger it gets. Hold me out, turn me on, never to forget. The more I can't neglect, the more I think it, the bigger it gets. Hold me up and turn me on, a double helix set, and I'm never to forget. The more I think it, the bigger it gets. The more I think it, the bigger it gets. The more I think it, the bigger it gets. Hold it in my space. I don't know your face, because I try to hold it in place. Vision total blur, like this world unheard. The birds are singing, or at least they were. Hold me out, turn me on, we're never to forget. A more I can't neglect. The more I think it, the bigger it gets. Hold me up and turn me on, a double helix set,
was The More I Think, the Bigger It Gets by Luke Davis. Luke, Min, Taylor, if you'd like to join us, that would be fabulous.
Hello, everyone.
Hello.
Hi.
Hello, everyone.
So first of all, we're going to start with Min and Taylor. So you're from the Nano Robotics for Health Grand Challenge. And this Grand Challenge is using nanoscience to design robots that are going to hopefully go inside people's bodies to detect disease and then maybe cure it. This sounds a lot like science fiction. Can you explain a little bit about what you both do as part of this project and what you do in the lab?
Yep, sure. Hi, everyone. So my project is focusing on building nanostructures out of DNA as material. And the aim of my project is to develop a toolkit that allows for users to build and structure at any size and shape to meet specific application. And nanorobot is one of the application. If someone comes to me and say they want to build a system that has an arm that's about 100 nanometer in length, that is something I could do. And that arm could be used to grab a cell, stick to the cell, and kill a cancer cell, for example.
There you go. So if that's a specification that you need, Min is the person you need to ask. What about you, Taylor?
Yes, I work on the protein side. So in our lab, we look at encapsulin, which is a type of protein that likes to stick to copies of itself. So it actually forms this giant, by nano standards, cage that you can put other things into. So, potentially you could put drugs inside or outside, target it to specific areas. You can put other proteins inside that do important reactions. So there's sort of wide application, which is really cool. And like, there's already proteins and DNA inside of your body. And so it's sort of reusing those and changing them and putting different ones in and having them suit a different purpose.
So reusing the robot or the machinery of the body, but into something that you've designed. It's very cool.
Yeah.
And Luke, you have created a song in response to the work that Min and Taylor do. What was it like kind of hearing the work that they do and then trying to figure out a way to put that into music?
It was a fun experience overall. It was a new experience for me, and it was mostly just exciting because I've been so fascinated by the scientific side of, mostly because I just started studying at the con this year after actually working for a couple of years on Get Clever, the show that Taylor sometimes featured, and I was editing on that. So I actually knew her from working at Channel 7. Which is very fun. So yeah, and then I decided, look, I'm doing music as well. As you mentioned in the intro, I've been doing a bit of that, and so the only experience I had in producing was all my own work, all my own kind of drive and inspiration. But to have something to work off, which has so much in it. Hearing from Min and Taylor, I had both of those aspects with the DNA specialization and the enzymes, the proteins. So I sat with the what I'd learned, because there was so much in that 1.5 hour Zoom conference call with them, so much to process, and so I kind of sat with all of that for about a week and kind of played in it, and just let ideas come rather than force an idea. And I'd recorded in my voice memos on my phone probably almost 30 different little ideas, and then this one kind of kept on developing, though. The more I think it, the bigger it gets. That just kind of came to my head, and I recorded, the more I think it, the bigger it gets, and then just built it up from there. Deciphered the kind of little melodic ideas that had come out, and then I guess when I was trying to think of words to fit into it, I didn't want to make it too explicitly detailed, but more kind of inspired from it. So the way this song kind of came about, I didn't intend on doing this, but I think listening back in retrospect, it's almost like the verse is written from say, the scientist or the researcher's point of view. And so is that repetitive loop, and then maybe the chorus is almost like the DNA or the enzyme singing, you know, pull me out. And it's also got that kind of robotic vibe to it. I just think it's amazing how you literally reprogram enzymes, as you say, that our bodies are already familiar with, and then get it to do amazing things like latch on to cancer cells and destroy them. It's wicked.
It's wicked. That's what Luke Davis says. That's got to go on the review of some of your work, Min and Taylor. We're going to hear more from Min, Taylor, and Luke. Fear not, everybody. This was just your short introduction to them until we get to the panel. But for now, thanks so much, Luke, Taylor, and Min. We'll speak to you in just a moment, and we'll move on to our next guest and our next track. So from the Safe by Design Nanotechnology Grand Challenge, we're delighted to welcome Dr. Hien Duong, who's from the School of Pharmacy at the University of Sydney. Dr. Hien Duong first won a really highly competitive Endeavour postgraduate scholarship and joined the Centre of Advanced Macromolecular Design in 2007 for her PhD. She's worked at a number of places since. In 2014, she joined the Key Centre for Polymers and Colloids at the School of Chemistry at the University of Sydney. And she was working on an ARC linkage grant there with the paint company, Dulux Australia, because this research is really far-reaching and there are so many applications to nanoscience, as you're hearing in the Life in the Lab project. She has over 40 peer-reviewed journal articles, which is very impressive, including Nature Nanotechnology, ACS Nano, Chemical Science, some of the top journals for those of you who are journal readers. And for those of you who aren't, you just have to trust me. And she is representing the Safe by Design Nanotechnology project, and we'll hear a little bit from Dr. Duong in just a moment.
And teaming up with Dr. Duong is, so P2X is also a Sydney-based artist, otherwise known as Phoebe Twig. Phoebe is a producer and qualified audio engineer. And Phoebe morphs audio into pulsing waves of emotion, delivering a sound that is delicately detailed yet powerfully destructive. And it swings between constant poles of tranquility and turmoil. Phoebe weaves an organically forming tapestry between the external and the internal world and smothers the senses, leaving drippings of various genres, references, and styles.
And we're going to hear some of that now, aren't we, Courtney? This is the piece composed by P2X for Safe by Design Nanotechnology for Live from the Lab. This is I Will Transcend Every Loss by P2X. will transcend every loss by P. Twigs. And if I could welcome Phoebe and Hien to turn on their cameras and microphones, we're going to hear a little bit from both of them now by form of introduction. Welcome.
Hello.
Hi there.
Hello.
So, Dr. Hien Duong, you're from the Safe by Design Nanotechnology Grand Challenge, which is a grand challenge that has, a really far-reaching goals, which is to as well as developing new technologies, to really assess the safety, the toxicity, the efficacy of different nanomaterials, and really provide sort of a blueprint for guiding future discovery in this area. Could you give us a bit of a feel of what you do as part of this project? What are you up to in the lab with your students and your team?
Yeah, so we are working on the using of nanotechnology in medicine, which is called nanomedicine. So basically, we develop nanotechnology in the form of the nanoparticle for the prevention and the treatment of the hard-to-treat diseases. And we are focusing on cancer and infection caused by antibiotic-resistant bacteria. So, over the last decades, a large number of new materials have been developed. Therefore, it's very important to evaluate the impacts of those nanoparticles on human health and environments. However, so far, we don't really have any standard toxicity assessment of nanoparticles. So that's why we develop models based on 3D tissue and also the AI, artificial intelligence. So from the data we have, we will use AI to analyze our observational data and then create predictive models. So our aim is to replace or at least to reduce the use of animal model, which is currently we really rely heavily on that for the assessment of the toxicity for the nanomaterial. We also develop biosensor to detect and track the fate of the nanoparticle in the environments and also in the body. So the findings, we hope that our finding will allow the Safe by Design nanotechnology and also enhance the speed and also the certainty for the hazard and risk assessment for nanomaterials.
That's fabulous. Thanks so much, Hien. I think, there's so many parts to your project, this grand challenge, that really resonate, but this ability to try and move beyond animal models is something that I know everyone would be keen to do in science, to be able to test things for safety and efficacy using computational models instead of animal models, which have flaws as well as ethical issues, is something that's really exciting to see. So thanks, Hien. We'll hear from you a little bit more later.
So Phoebe, you learn about all of this work that Hien's doing, and then you're like, oh, true, now I have to put this into a song.
Yeah.
What do you do?
I try my best. Yeah, it's really amazing learning about it. And I kind of thought of it, like when I was making the song, I kind of thought of the nanoparticles traveling through the body and like specifically finding the cancer and eradicating it like that. That's kind of how I thought about it. And then with the idea of like the name, I suppose it's like with every loss, with illnesses, there's like always going to be something that science is trying to reach and modify and help, in sickness. So that was kind of where the title came from. But yeah, I just almost like focused on the nanoparticle traveling through the body to eradicate the cancer and what that would sound like. And the body almost like thinking of it as like a machine in a way. Yeah. Try my best. But yeah, it's amazing research. Right? And yeah, it's really, really cool to do.
So good. I really like the way that, you're describing that visualization, because you can kind of see, like, I don't know if this is what you did, but I imagine that you're like watching that in your mind's eye and then kind of, playing around with the sounds until it kind of matched what you
Yeah, definitely. It was a visual experience. And then just getting that out, because even when it was explained to me, I saw it as a visual thing, and then just getting it out to like a sonic kind of level was, but yeah, it was really, really cool. It was a good challenge.
No, I was just, when I interrupted at the wrong point there, I was just saying it's an amazing research, but it's an amazing piece. And I think, you know, as I've listened to it again and again, you can feel that journey of that struggle, that nanoparticle. Maybe just a note for everybody that the researchers heard these pieces for the first time live on FBI radio. They hadn't heard them before we went live last week. But due to some of the audio that you lose when you're trying to play track through both the radio and Zoom and through a desk, I think for some of the songs it was difficult to feel the full impact until you heard the recording there. And I think certainly, Phoebe, yours was one of those that it was difficult to hear the full complexity of the piece. So I hope that, you know, I know Hien's now listened to it more and maybe gained even more from the track from listening to it again and again.
Yeah, I think, yeah, there's a lot of detail in it that you do lose with compression formats, you know, so it's not going to sound the same listening to it through a computer, through something else, you know, it's always, so it's nice to hear it direct from the source. So
no, for sure. Thanks so much. We're going to hear from both of you again a little bit later, and we'll introduce our next partnership and our final partnership for today's discussion. So we'll move on to the partnership that was formed in response to the Advanced Capture of Water from the Atmosphere, or AQUA project. You can see what they did there, a very clever name. And we're going to meet the partnership that was formed in this project in just a moment. I'm delighted to introduce the scientist, Professor Chiara Nito, who's a colleague of mine from the School of Chemistry. Chiara originally studied for her undergraduate and her PhD at the University of Florence in Italy, and then she moved a couple of times to Germany and then to ANU, and then she found her home at the School of Chemistry at the University of Sydney. Professor Chiara Nito is really interested in the physical chemistry of interfaces, of surfaces, of things that sometimes you might not have thought about too much, but Chiara and her group think about all the time. And they're taking inspiration from nature and looking at ways that they can maybe replicate some of the natural phenomena that enables natural surfaces to have some of the properties that we might want to emulate. So imagine self-cleaning paints, or improving water scarcity in arid areas, which is the topic of this AQUA project.
Nadine was born and raised in Sydney's West to an Egyptian family and began exploring music at the age of 22. And after just a few short years of exploring her voice, has cemented herself as a force to be reckoned with. Nadine effortlessly traverses rap, singing, and poetry in a genre that Nadine describes as post-pop, influenced by hip-hop, while also and after releasing her debut.
Courtney? I think we've lost your sound a little bit, Courtney. We're losing this lovely introduction to Nadine, I think. We couldn't hear what you were saying after the first little bit of her introduction.
Oh no, can you hear me now?
We can, yeah. Do you want to take it away again?
Where did you hear up to?
I think start from the top so we can hear more about Nadine.
Okay, sure thing. So born and raised in Sydney's West to an Egyptian family, Nadine began her musical exploration at the age of 22, and after a few short years of exploring her voice, has cemented herself as a force to be reckoned with. Nadine effortlessly traverses rap, singing, and poetry in a genre she describes as post-hop, influenced by hip-hop, while also drawing on elements of neo-soul, electronica, and glitch. Nadine released her first record in 2019 and has just released her second EP, The New Era.
Thanks, Courtney. Sorry, I wanted to capture that. And now we're going to hear Nadine's composition in response to the AQUA project. This is Nano Steps by Nadine.
capture it one by one. Do you ever think about how many nanometers between you and who you really are? We go 1 drop, 2 drops, 3 drops more. Oh, there's molecules in the middle between 3 and 4. One idea, 2 or 3 more. Give yourself some time. There's more detail than you thought. Take nano steps, it's still progress. Each tiny piece completes the rest. Take nano steps, it's still progress. Each tiny piece completes the rest. Well, I don't know about you, but I seem to worry too much. Think about the future, hurry and rush. Master each day, you'll master the rest. Break it down further, just master each breath. Think how many photons it must take just for me to see my lover's face. Think of all the space that's in between, all the thoughts that always seem to give me grief. Take it one layer at a time. Millimeters still make a line. Every single atom inside every single drop is what makes it tie. Take it one layer at a time. Millimeters don't make a line. Every single atom inside every single drop. 1 drop, 2 drops, 3 drops more. Oh, there's molecules in the middle between 3 and 4. One idea, 2 or 3 more. Give yourself some time. There's more detail than you thought. 1 drop, 2 drops, 3 drops more. Oh, there's molecules in the middle between 3 and 4. One idea, 2 or 3 more. Give yourself some time. There's more detail than you thought. Take nano steps, it's still progress. Each tiny piece completes the rest. Take nano steps, it's still progress. Each tiny piece completes the rest.
That was Nano Steps by Nardine. And if I could invite Nardine and Chiara to turn on their mics and videos and join us, that would be fabulous. Hello there, Nardine and Chiara.
Hi.
Hello.
Hello, welcome. So first of all, we'll go to Chiara. So Chiara, you are co-leading, along with Martin de Sterper, the Aqua project at Sydney Nano. And this project is looking to find a low-cost method for basically pulling water from thin air to hopefully alleviate the effect of drought by providing water for humans and animals and plants. What does a day look like for you, Chiara? What are you doing in your laboratory, or what are your students up to that contribute towards this in terms of the science and the thinking towards this project?
Okay, so my side of things has to do mostly with fabricating the surfaces that will do the water capturing. So I have 1 PhD student, Ming, and 1 postdoc, Ricardo, who are working, Ming on designing the surfaces, and Ricardo on building apparatus that will allow us to test how good our surfaces are. But more in general, I'm part of a very large team across different faculties, so engineering, science, and within science, there's both physics and plant science and hydrology, and then there's architecture and design. So many different disciplines come together because, as you can appreciate, if you're going to have a device that gets water from the atmosphere, then you also have to work out how's it going to impact, so for example, climate, the microclimate, how our plants going to be impacted if we use it near plants, and how we're going to build this. This is going to be a product that people are willing to pay money for. So, you know, all these components that we don't have in-house, we can find across the university. And that's what the Sydney Nano project has allowed us to do, to put this team together.
It's fabulous. Thanks, Chiara. So, you know, I think this is something that comes up again and again. You know, sometimes when people who don't work in science, sometimes we have this idea that there's one single lone brilliant scientist. And this is so rarely the case. Often in history, this has been the case because sometimes, often a white man has been given the credit for a discovery, but we really don't get very far unless we work together with people from all different backgrounds, all different perspectives. And the emphasis here, right, in the Grand Challenges is on teams and collaborations. And it's great to have been able to extend this collaboration to a musical one with Nadine. So I'll pass over to Courtney.
Hey Nadine, so you learnt about this stuff. What were the steps that you took once you learnt about the work that Chiara does?
Well, there were nano steps. That's
hey, I was hoping you would do that.
Thank you. Set up. I appreciate that. So I did when we did the chat, I definitely was just taking notes and obviously trying to find the poetry in the whole thing, like what was beautiful about it. And again, I find science really fascinating as well. So I was really excited to be part of it. And then, and a lot of my songs kind of talk about sciencey concepts anyway. So I was really excited to have to speak to an actual scientist. But I took notes, and then, I kind of, if I'm honest, I didn't do a lot of sitting down and okay, now I'm going to work on the song. I was really lucky in that this was one of those, sometimes as an artist, and actually, you know what, I would say as a scientist as well, you can sit at your desk and work on something, and you have to kind of chip away at it and work away at it. And then sometimes ideas just come to you like butterflies that land in your head. So definitely for this song, I kind of just was mulling it over, and then I think the first thing that happened was just the word maybe nano steps just popped into my head, and I found that really beautiful because the other reason, so obviously there's working at a nano level and capturing drop by drop and the little things making a difference, but there was also that added layer of Chiara telling me that they'd been working on this for 10 years or something like that. And I just had the thought as well of going to the lab every day and one small discovery after another, or at nano steps, one small thing after the other. And you end up with one drop, every single atom inside every single drop makes a tide. One tiny discovery after one tiny discovery, can help fix the problems that drought creates, so that was, that was something else that came out of that for sure.
Yeah, I love that thinking too. And just kind of, the symbolism of the grind of just chipping away at your work or your craft, whatever it is that you're working on, and just being okay, we're just going to keep on keeping on. We're going to get there. Sometimes it's baby steps or nano steps. Yeah.
Thanks so much, Nadine and Chiara. I think now we're going to invite everybody to switch on their mics and their cameras and to join us for a bit of a panel discussion. That sounds very formal, really a chat about the process and to see and hear from people's different perspectives. So I think everyone is on. Hey, there's Phoebe, great. Luke is coming back, great. So we can see everybody. So maybe I'll start, and then Courtney and I will sort of take it in turns to ask a few questions, but we also really, really warmly invite the participants to ask questions. That includes people who are on the panel. Please ask questions of each other. This is a discussion. It's not a formal interview. So write them up in the chat if you're happy to. Those of you who are in the audience, we'd love to hear from you. So I was just wondering I'll go and ask the researchers a question first of all. have you ever been part of any kind of collaboration before that has brought art and science together? So music, art, anything creative that has helped you to explain or to expand on your scientific horizons. Maybe I'll start with Chiara for this one.
Sure. So I've never worked with a musician before, so this was very exciting. But I had an opportunity to work with visual artists. So actually with you, Alice, we are part of a project called Nano Lens, where we try and bring together, I guess, more visual arts and science. We've produced a program where we bring to the public nanoscience images, and in particular, images of natural surfaces. So for example, images of flowers and leaves that have a nanostructure. And so side by side, we show to people, this is how a scientist looks at nature. And so, you know, a scanning electron micrograph of a leaf. And then next to it, we put a beautiful piece of art. In particular, we were showing art of Margaret Preston, who's an Australian artist who's depicting a lot of native plants, and showing how an artist looks at the same type of specimen, for example, a Banksia flower. And there, you know, we were really trying to highlight there's a lot of similarities in the process. A lot of it is about looking really carefully and deeply at nature and natural specimens. But then, of course, each side has their peculiarities. So I think in art, it's often about creating a unique piece that can never be repeated, you know, because there's inspiration in the moment and nobody else could do the same thing. As opposed to in science, you often want to say, I've made this measurement, I've made it 100 times, I always get the same result. And by the way, if you did this measurement, you would also get the same result. And so I think in many ways, I find it very interesting to see the opposing ways and also similar ways in which scientists and artists work.
Thanks, Chiara. That wasn't supposed to be too much of a Dorothy Dixer, but I did ask you a question I knew you could answer well. Taylor and Min, what about you? Have you ever collaborated with artists before, or thought about sharing your research in an artistic way? Taylor, I know you're a seasoned science communicator. How does that kind of feature in the way you share science with younger audiences, for example?
I've done, so I spent a couple of months at UTS, and while I was there, I was sort of running this program called Steampunk Girls. So it's about STEAM, so STEM and the arts. And I was working directly with young women in secondary schools and their teachers as well, and coming up with projects that they could do to combine science and art, including like arts, humanities, and all of it. And it was really amazing seeing like how closely intertwined the arts and the sciences are, and how similar those processes are, those thought processes. And so that was sort of my foray into the world of combining arts and sciences. And then I've always found like with students, especially just making an inquiry creative, but then also having them learn a scientific concept and then use that as a way to solve a problem. And I guess during my time with Steampunk, I got really into soaking things in red cabbage juice. Which is a pH indicator. And so if you put lemon juice on it, it turns bright pink, or bicarb on it, it'll turn green. And so I would have people sort of come into like sessions about STEAM, and then they'd have to paint like an artwork and then be like, oh, well, that's just lemon juice and that's just cabbage paper, and sort of teaching the science behind that as well. So this was my first time sort of using or finding a way to collaborate to use art to describe the science that I do. And it was really amazing. And it was very different from my past experiences.
What about you, Min or Hien? Do you have anything to share?
Yeah, actually, this is my first time to, I didn't think much about the collaboration between music and science until I joined this project. It's give me a higher level of thinking, whereas the music might allow us to interpret the data in a different way in which we could never see with our eye, because the eye and ears, they work very differently, but they all connect to the brain and logical thinking. So I think the music provide a different way to interpret the data and recognize pattern that might be useful and interesting for science exploration.
Thanks, Min. And Hien, what about you?
Yeah, it's first time for me too. So, you know, I always present my research using traditional PowerPoint presentation, right? So it's really excited to present my research in a piece of music. That's why I found that it's really amazing. So when I listened to the piece of music that Phoebe created, I say, wow, so how she can convey that all the emotion within this piece of music, even without the lyrics, you know. So I think it's not an easy task at all, but the way how she creates this piece of music make me can imagine like the cancer cells is like moving along in the darkness and find the cancer cell and then attack the cancer cell, and then I can feel the cancer cell eventually they are dying, you know. So it's amazing how she can convey all these kind of like research concept into the music. So it's really amazing for me. So I was really emotional when it was the first time when I hear in the live in the lab on the FBI radio. It's amazing.
Actually,
Yeah.
sort of, I felt the same way. Like I was, like I felt more emotional than I expected to.
Yeah.
I think afterwards, like I listened to it, I was like, oh, this is what I'm doing in music. It was, yeah, it's a very powerful thing.
Yes.
Yeah, no, I agree with that. You know, this wasn't about my research. And at different times throughout the project, I explained this on the radio. Courtney heard me say this every day. Like I made my own little EP of the tracks and I was listening to it on repeat. And at different times, you know, maybe I'm just a big softie, but each of the pieces like made me cry at different times. And then finally, when on the end of the week, maybe I was a bit tired, but Nadine and Kiara were on. And all the way through the interview, I could just feel these little you know, I was capturing water from the atmosphere down my cheek, because I think there is something really emotional about each of these pieces that are very different, but they convey something about the passion that the scientists have, but also the reason why you're doing this research. You know, why you're motivated to do it. And I was a bit surprised by how you know, how emotional I felt. I think Nadine, did you want to say something?
Yeah, once you finish your point, but that
No,
was me just like, oh.
That's my point. I'm rambling on like
Yeah.
a big softie. So there you go.
I have a little theory, and you know, I say this around kind of non-scientific people, and it like it's, look, it could just be a load of baloney, but the way I think about it, and it's like this would be my explanation for why it would be so emotional for you guys hearing that. And it's rudimentary, but this is it. It's like, so everything, like for me, songs are just frequent, like they have a frequency to them, they have a resonance, and they have a like an energy to them. And like, for example, when I write a song, it resonates, it like perfectly matches up with me because I've written it. And so I feel it really deeply and I'm connected to it. And sometimes if I record a new song, I will listen to it over and over and over again, because it's like almost like attracts like, you know, just like it fits perfectly with me and it like hits a certain point within me. And so I feel like with all these songs that we've written, because they're all like kind of resonating at the frequency that you guys gave us, essentially, it was like your own work, and you gifted us with the ideas and the inspiration. It was like your energy went into these songs as much as ours did. So I can see why it would be emotional for you guys to hear what you've given us translated back at you at like a slightly different wavelength, you know?
Yeah. And I must say, I've thought about this quite a lot too, because from the very first day, I found it very emotional too. I wasn't sure why that is. And then it occurred to me that it's a little bit like if you hear somebody speaking about your children. I don't know, and this might be a bit exaggerated, but it does feel a little bit like that. So just allow me a little detour. Just recently, I got my group to do like a journal club where everybody reads a paper and reports on it to the group. And I asked them to choose previous papers from my group, you know, from a few years back up to 20 years back. So each of them read the paper and then reported on it for 10 minutes to the rest of the group, right? And when they were doing that, I was really feeling, you know, thinking about the student who had done that work at the time, or the group of students, and how it all progressed, and how it, you know, maybe at the beginning it didn't look so good, and then at the end we found what we were looking for. Whatever process went into that paper, you know, all came back. And this is a little bit similar in the sense you know, somebody else looking at this product of your labor, and you're really proud of it, and you know every aspect of it, and what they choose to highlight, you know, all of a sudden you see it in different eyes. And well, of course now in this case it's a lot, you know, it's full poetry what came out of Nadine. So it's even like, oh my God, this is such a powerful way to describe it that I had never, you know, could never think about. So yeah, it goes quite deep. It's impressive. And I guess, I mean, I don't want to preempt your future questions, Alice, but I mean, for me, the magic would be, is it possible to get other people to feel the same about this music, you know? And whether if they hear a little bit about the research and then hear the music, will that also give that to other people or not? I don't know.
What you said, Kiara, just at the end there, I think like absolutely, but what I love about it applies to all art, not just songwriting, but it'll mean something slightly different to the person listening to it. You know, it might be someone who has no idea that it was commissioned to be written in response to some scientific research, and just the way Nadine's singing it, that the words just might mean something really deep to that person, which is really cool.
Yeah, I think of music as like a universal language, you know, like we can all kind of tap into it and understand it. So I think it's a feeling, you know, and it can describe so many things, and people can really take so many different things from it. So it's kind of like non-linear, and it's also like universally shared collectively. So
I think that's sort of like the power of this project, because I feel like sometimes science gets a bad rep, that it's this like cold, unemotional, like string of facts and like knowledge and stuff. But everyone who does it is so emotionally invested in what they do and so passionate. And I feel like through music, it's a way of sharing that emotion or that feeling with a wider audience in a way that resonates with them and sort of sees like how we feel about what we do every day.
Scientists are the true rock stars.
so true. I think like it's at each of their cores, because I heard when I was learning a lot about poetry writing a few years ago, what I really liked, someone's definition was that poetry is the pursuit of truth, and obviously science in a way is as well. You're trying to find that absolute truth in whatever little aspects that you're specializing in, but in the greater sense, throughout history, science has always been like, no, let's revisit that and find the truth. And it's almost like that's for the external physical world, and art is a reflection of the inner truth, kind of trying to find and constantly challenge it.
Yeah, and the thing I like about science, I suppose, is there's no absolute truth. You know, like there's only a truth that you get to at that point, and it doesn't mean it's absolute. So it's constantly changing and constantly progressing. You know, it's like such a progressive thing, and I think a lot of scientists are so progressive because of that.
And I wonder if that's part of the treat of having a song that, no nano puns intended, but that encapsulates a moment or encapsulates a time in a research period. Because, you know, as Kiara mentioned, you know, she's looking back through all these papers in the group, but science is never finished. It's never complete. You know, there's always something more to learn. So one of the things that can be both exciting and difficult about being a scientist is that it's like, when is the project over? Because
Yeah.
it's often never over, but to have, you know, that's why in a way papers are so exciting, or conference presentations, because they mark like a little bit of closure, or a little bit of tidying up, or an event. And these pieces of music, they're a moment in time that describe where the project are up to, even though they're not solved. We've not solved water capture or cancer drug delivery or nano robots. And that's part of what's so exciting, right? Is that they're not finished. They're works in progress. And so I don't know if that's part of why it's quite exciting to have a piece of music.
Totally. There's a Nina Simone quote where she says, like, I'm paraphrasing, but it's something like, it's the artist's job to reflect the times. And I think that really it's kind of like the human's job to reflect the times, you know, like we're all just like a product of this moment and where we are right now. And to have you guys doing that research and like pushing, you know, tech forward and science and knowledge forward in that way, and then to have us like kind of checkpoint and marker it. And for us, it's like, it's even a place in our lives as well. Every song you write is, you know, is a checkpoint for yourself. I'm sure, you know, heaps of you guys, the artists, would relate to that. So yeah, really quite a magical thing to be part of.
We've got a question in the chat there from Gunther saying, will the music inspire your research as the musicians are inspired by your research? For the scientists.
Well, I've been trying to think of ways in which, along the lines that we were saying now, you know, I've been playing the piece that Nadine wrote to my third year physical chemistry students. I started lecturing this week, and I play the piece at the beginning of the lecture while students are coming in the Zoom calls. It's all done online these days. And, you know, I want them to like, oh, you know, sit up and listen to this amazing thing and listen to the words and what it's saying. But obviously I can't control what gets through to them. Or also, you know, the playing quality over Zoom is not great. But what I would like, I guess, is for the music to be able to make a bridge between what I'm doing and the rest of the world, right? So if it can give me a way to communicate enthusiasm or passion for science, or even just the process of science, you know, these nano steps that Nadine talks about, then it would be hugely influential, right? It would really help me to talk to non-scientists about what I'm doing. And so from that, yes, I can learn a lot how to do that better.
Did anyone else have an answer for that one? Would the music inspire your research, or have you also played it in a class or anything like that, or to friends or family?
I made my husband listen to it on the whole car ride to uni after the morning we were on the radio.
Good one, Taylor.
Yeah, it was good. It was good. He liked it as well. But I think for me, it's actually kind of a nice reminder. The more I think it, the bigger it gets, because I don't know, I get really lost in the details sometimes. Like I'm working on like one small thing and like throwing everything into it, and it's not working, and I'm getting really frustrated. And it's like a reminder that like this is only one small part of this really big thing. And so yeah, it's kind of helping me research better in a way.
Motivation.
So reminding myself that, yeah.
Yeah, I love that. And Hian?
In general, I love music. So I would say I can't live without music, you know. I'm listening to the music like all the time, even when I'm cooking, driving, you know, or even working in the lab. So if the experiment is not working, music is good. It gets me through this, you know, it's a challenging time. So I think it's good. And even though the music can convey my research, is even better. So I think it's fantastic.
Yeah, and what about you, Min?
Yeah, I actually feel the same way as him. So the music make me feel more relaxed and work more productive in the lab. And especially if there's a lyric that somehow relate to not directly but relate to the broader pictures of what I'm doing. It's a great inspiration. For example, the more I think, the bigger it get, and I try to making a very big structure. So I think more.
Yeah.
Yeah.
I'd be interested, Min, I don't know much at all about computer science, but I know you work with the kind of computer program building the template, I guess, for the DNA before it gets sent off to the lab to make the physical DNA, to somehow like take the programming of the physical structure and reroute that or something to generate a sound representation of the graphics. And then I don't know, just an idea of how to approach some sound creation from a more technical
So there are some projects like that. I think a colleague Holly sent me some after last week's panel discussion, because the thing about DNA is that because it is so modular, because each piece is a distinct chemical, like it has a distinct structure, you can kind of describe quite easily sonically the sequence of DNA, right? By having 4 different sounds or 4 different notes that describe each of the bases. So I think there are some kind of weird and wonderful pieces of composition. And a lot of people doing work in terms of, sonifying science. And they're very cool, very interesting to hear, DJs who program sets according to some of these kind of resonances, music, information. I think the thing that was particularly cool in this project was that there was such emotion behind the composition, so that it wasn't like the science leading a process of notes or a process of sounds. There was this human element of interpretation too.
Exactly, which is kind of for me the only place I really knew where to work from at this stage. But it is interesting because, as you said, it's an interpretation. It's us interpreting it, and then having an emotional response and responding to it. But yeah, there's so many different ways it can be done. Same with, as we were saying before, same with scientific research. So yeah, this whole project has just inspired so many thoughts for different similar projects, which is cool.
I'm just trying to think about how it would actually work, because that's such a great, I hadn't thought about that, Luke, and it's such a fascinating idea. But I'm thinking of what I know about DNA and how it, I don't know much about your research, Min, but yeah, what I know about DNA and how it's it goes off a sequence and it's A, G, C, whatever. I don't know what the actual letters are, but yeah, I feel imagine, their notes on a piano, imagine just assigning that and seeing what melody, what melody I am and what melody you are, and then finding, that would be super cool. That's such a great idea.
Melody a banana is, because apparently our DNA is very similar.
Banana song. We could write
cool. It's really fun.
A, G, and C are doing well, and then T has to ruin everything.
Yeah, well, we could assign T something. Maybe T is just a different. Maybe T is a silence.
Actually, the T is the very gentle one. G is we don't want too many J's. So. J's are the heavy stuff. Maybe strong notes on the piano, maybe.
Yeah.
Maybe
save it for the outro.
Yeah.
Phoebe, I wondered for you, as somebody who composed a piece without any lyrics, what makes you make that decision about whether to use any lyrics, what to use any refrain, or whether to use to compose something that's completely electronic? How difficult or easy is it to convey that emotion without having lyrics to add to your piece?
Well, I suppose, like Hian, with the research using artificial intelligence, like I use a lot of digital software. So in a way, I interact with artificial intelligence when I make music. So I kind of think of it as like an extension of me working with science in a way, or working with the digital technological domain. And I think there's a lot of magic in that world, in the digital world. So I don't know, I think it kind of transcends into emotion. A lot of people think that, you know, digital wouldn't be emotive, but I kind of feel like it is now.
Yeah, okay.
It's hard to, but yeah, I use a lot of lyrics in my music as well. It's very rare that I sing. So it just depends on how I feel, I suppose. I just didn't think this needed singing on it. Yeah.
I think the imagery, as they were saying before, the imagery is so so on point with what we heard about the research. Having a context for the research and then just going inside the body and hearing the process of what was happening, was the representative sounds were like so clear. But yeah, I think obviously like it would be so interesting to hear someone's interpretation who didn't hear about the research before and just how they dig it or what it would do for them. But yeah,
I suppose it also like it's also like how you make music as well, because now there's so many different ways of making music. You know, we have so much like ability to make it just on a laptop, or we can make it in like physical on a piano, you know, like, and it's all kind of, it becomes one in the end. But there's so many different ways you can make it that I suppose I was more working with the digital domain and then making that like a body, but it was a machine, you know. I don't know. Hopefully that makes sense. I don't even but yeah, I did it.
And before we wrap up, I just wanted to jump off that idea of like, you know, we've spoken about the visuals that you saw, Phoebe. What about Luke and Nadine? Did you have any clear imagery that kind of came to you when you were hearing about the research area that kind of inspired you to make sense of it?
The hearing about how DNA is folded up and manipulated was, I guess, an image that, yeah, inspired the chorus lyrics, at least for me, as is pretty obvious. Fold, fold, fold. And I guess also the repetition of, you know, that delay effect was also inspired by that, just having so many of the similar almost copies. And not so much, it's not so much an imagery based thing for this particular song for me, but I guess the story, because I had two kind of things to work with, as I said, the enzyme protein based one, and then the DNA manipulation. It's it all tied in, I guess, to because it's almost like what we're trying to be or what we are. Like the DNA knows that it's that. And I did some research, you know, revised my evolution knowledge and stuff with some documentaries, and just how we came to be through just micro or nano mutations in DNA over centuries, which millenniums. And so yeah, it was kind of like relating that, I guess, the work that you guys do with the DNA to the personal work I do, and perhaps we do as humans, trying to figure out, like, you know, trying to forget at some point in your life. It's like never going to change, you know, like I found my identity, and then this is like, I'm trying to forget, like you know, everything's a process. I'm a process. It's never set. And so I guess it was, to answer your question, I didn't have any specific imagery. It was more that kind of emotion and just really relating to my life.
Yeah, that's fair. What about you, Nadine?
Yeah, I agree with Luke in that it was more the feeling. And sometimes I do get pictures, but this time it was definitely more the feeling of, yeah, like just the tininess. Is that a word? Tininess. The nanosity. I meant to put that one up. It was more like, yeah, it was more just the feeling. And the one thing that did stand out to me as something that I'd never just computed before, or like a place, you know how sometimes someone just says something and you're like, yeah, that's totally a thing, but I've just never thought that before. It was like the Kiara telling me that she looks at like the first few layers and of things, so plants, for example, or beetles or whatever, and that the first few layers, like, and they, you know, mimic the molecular structure of the first few layers of things. So that for me was, that was probably like the image that I liked the most, was like, and that's what, you know, I have that lyric in the song that's like, take it one layer at a time. So yeah, breaking things down like that small. So definitely like that was probably the image that stood out to me the most, but it was more of a, yeah, it was more the feeling of like the smallness, like, because a lot of my older songs and a lot of my work has been like about how big the universe is and like zoom out and chill out and like we're just so insignificant, so like relax that you missed your bus is my normal kind of is my normal shtick. But yeah, this was more going the other direction. That was the piece that felt significant.
Well, it feels like based off the response from everyone here that emotions certainly come through. And, you know, I'm not a scientist or a musician, just a fan of both. And I felt very emotional, especially when it all happened on air and I was watching it unfold. I was like, whoa, I get to be part of this. This is so special. So thank you all for being part of it.
Yeah,
thanks Alice for, I mean, that's all right.
I think with that, it's time for us to wrap up. We've run a couple of minutes over. We tried to keep it exact to time, but we're not on radio, so we can go over a little bit. So yeah, thank you so much. It was so great to hear from you all today. Thanks so much for coming to our audience today. This will go up onto YouTube at some point. You can follow up with what's happening with the Live from the Lab project by visiting live-from-the-lab.com and seeing what's going on. I'd like to thank Nadine, Kiara, Min, Taylor, Phoebe, Luke and Hien. I'd like to thank all of the audience. I would love to thank Courtney Ammenhauser, who is the wonderful host and host of Up For It on FBI Radio. If you don't listen to her every weekday morning, what are you doing? You should start tuning in from next week, 94.5 FM. We'd love to thank the Sydney Nano Institute for their support of this project and the Nanosonic Stories team. My colleagues there are the wonderful Dr. Kiara O'Reilly, Dr. Danny Yeadon, and Dr. Nazim Ahmadpour. All of them are wonderful. And we'd also like to really thank FBI Radio for partnering with us as part of this project, and Inspiring Australia for giving us some National Science Week funding, and all of you for listening. If you can tune into FBI and support FBI, we'd love you to do that, and we'd love you to keep up with what's going on in this project. We wish you all a wonderful weekend, and thank you all for coming today. Goodbye.
Thank you.
Bye.
See you, everyone.
Thank you.
Bye.
Thank you. Bye.
Thanks.